Hey, 4700 students. So we're back and we're going to do some constructions here. And so one of the things we can do is let's construct a right triangle. So what I'm going to do is I'm going to do some segments. Construct it. And here we go. And there's a right triangle. Well, it looks right. Let's see. Let's measure the angle. And, ooh, it's close. So what we can do is we can drag this point and see if we can get, oh, there it is. So now we've constructed, but did we actually construct the right triangle? This is actually a drawing because if I drag any of these points, it's going to ruin this. And so you really won't get the benefits of dynamic geometry because you won't keep this right. So that's what we want to do. So we're going to delete this and let's construct a right triangle. So what I need to do is I need to start with a segment. And then I need to make a perpendicular line. I'm going to make it through point A to this, and now I have this right angle. So I need a point on this line, and this point C is a child of this this line G. So it stays there, and now I need to complete the right triangle. And there we go. Except if you ask my daughter, she would say this looks like a flag. So I want to hide the line, but now it doesn't look like a right triangle, so I need to put a segment here. And then let's measure the angle. And voila, there is a right triangle. If I drag any point, this will remain 90 degrees. So what's a popular theorem we could investigate with this shape? Well, how about the Pythagorean theorem? So we use the input bar here to do some calculations. So Pythagorean theorem says a squared plus b squared equals c squared. But we don't have a, b's, and c's. We have i's, f's, and h's. So let's go I squared. Let's calculate that. You can see they gave this number up here, which is I squared. I need F squared. And then I'm going to type in H squared. Okay. And so I want to show that A squared, or I squared plus F squared is equal to H squared. So A was I squared, so we can say A plus B, and there it is. Now, that doesn't really look great. If I was one of these students, I want to write a text box. I'm going to put a text box here. I'm going to say I squared plus F squared is equal to H squared. Okay, well that just has the formula. We actually let's put the values. So this would be A plus B is equal to C. But that's not giving us the numbers here. You know what I forgot to do? I forgot to use the objects because we have defined objects A plus objects B is equal to objects C. And now it actually gives us the values. And you can see here, there. And if I wanted to do the third text box and show that our value D, which was when we added them together, is equal to our C, we can do that. So if I line these all up here, and then I come over and drag, you see no matter how I make this, they always remain the same. Okay, so that's pretty interesting. So this is a construction. The drawing is what we did earlier. We drew it and we were able to make it, but when we dragged, it wasn't going to remain 90. So this is actually a construction. All right. So we can also do another interesting theorem, and actually investigate the geometric mean and show it works. The geometric mean in a right triangle, we have to actually create the altitude from the right angle to the opposite side. And so we need a perpendicular line from this point to this line, and then I need to do the intersection point. There we go, there's D. So the geometric mean is that the measure of CD times the measure of DB is equal to the altitude AD squared. And that's because you have all these, you have three similar right triangles here. So I don't like the line there, so I'm going to hide the line. But I need to put some segments, and I need to look at some measurements. So I need to put my altitude there. And I need this segment and this segment because we're going to use those to do some calculations. I really don't need H. It's going to make it difficult for me. Okay. So I need to calculate L, which is CD, times M, which is dB, and that's that value. And then I need the value of K squared. And those are equal. So if we want to put that in a text box, you can see that what we're going to do is we're going to say L times M is equal to K squared. Okay, there's that value. And if we wanted to do the value of the numbers, this would be, let me see, objects L times object M is equal to objects N. Hit OK on that. I can put this in line with equal signs, and then I can show one more text box. Go to objects. This is E. Is it correct? Where's E? Where are you, E? There you are. E equals objects and N. Hit OK, and you can see that again. Now, as we drag these points, the geometry mean always remains the same. So we have created the geometric mean and shown that it's true no matter how we move this. So the big thing when we construct is we want to construct things according to their properties and use those. But sometimes we can make over constructions. So there's a difference between over constructions and under constructions. When we were doing those drawings, that was an under construction. It would work for one case in particular, but when you drag, the whole thing fell apart. Now this is a nice construction because no matter how I drag it, I can make any kind of right triangle and it stays that way, so it's not an under construction. But it's also, it can go to any kind of right triangle. If I wanted to do an over construction of right triangle, I could use a segment. I could take this segment, and then what I could do is use a transformation and rotate about a point. So when you rotate, you select the object, center point, and then enter the angle. So I'm going to select the object, the center point, and I could rotate it 90 degrees. Okay. And so then I can finish off my triangle here, which is great. But when I drag this, so it's definitely a right triangle if I measure the angle. I think it might give me the exterior. It will. Oh, GeoGebra. Let's try it again. There we go. So I get my right angle. And then as I drag this, you can see that it always stays a right triangle. The problem is that P and what P prime here is I've constructed a very specific kind of right triangle, 45, 45, 90 triangle. So what we want is we don't want under constructions that fall apart. But we don't want over constructions, because if we thought this was a general right triangle, then we can come up with some very erroneous ideas, and students would develop misconceptions of that. So we don't want, it's like the three little bears. We don't want it to be Big Bear where it destroys into everything. We don't want it Little Bear where it becomes just very specific. We want it right in the middle where it does all kinds. So what I want you to do is in the description sheet is to construct some different figures, and then you're going to upload them to the materials page at GeoGebra. And the next video will show you how to do that.